Yosemite National Park's geological setting. Introduction. Yosemite National Park is located on the western slope of the Sierra Nevada mountains in northern California's Mariposa, Madera, and Tuolumne counties. It is one of the most recognized national parks in the United States, home to various natural features, including cliffs, rocky outcroppings, waterfalls, and valley bottoms. This paper aims to synthesize the information available on the geological setting of Yosemite National Park and discuss its formation. Yosemite National Park. Over 100 million years ago, the granite bedrock that forms the foundation of Yosemite National Park was sculpted in the subduction zone. Initially, shallow seas influenced the formation of sedimentary rocks in the region when it was a part of the continental margin. The gradual subduction of the Earth's plate metamorphosed these rocks. As a consequence of this event and volcanic activity, volcanic islands were formed west of the North American coast. The islands were covered in magma, resulting in the intrusive igneous rocks known as batholiths in the Sierra Nevada mountains. The great bulk of Yosemite is formed of plutonic igneous rocks. They develop when the molten rock solidifies and slowly hardens, enabling the formation of crystals. In comparison, volcanic igneous rocks occur on the surface layer when molten rock cools fast, forming microscopic crystals. Gabbro, diorite, and quartz diorite are plutonic rocks present in Yosemite. 5 minerals constitute the plutonic rocks: quartz, plagioclase feldspar, hornblende, biotite, and potassium feldspar. Plutonic rocks, mainly granitic rocks, vary in the relative quantities of feldspar and quartz. As a result of a volcanic eruption, the park is home to basalt flows, latite tuff, ash flow tuff, rhyolitic rhyolite, pumice, and obsidian. A characteristic feature of the Yosemite region is exposed granite. The term granite encompasses many minerals, including diorites, tonalities, and granodiorites present within the 10 plutons identified in the Yosemite Valley's walls. The granite masses of Yosemite's rocky formations are continuously being exfoliated. During the removal of the exfoliated granite layers through erosion, the new joints form and round out over time. Exfoliation occurs when the rock expands because of the reduction in pressure, forming Yosemite's curving joint forms. In addition, glaciers and rivers significantly altered Yosemite's landscape. Rivers led to the construction of valleys and canyons, while glaciers contributed to their depth. Another result of glacier activity is the refined granite on the elevations from whence the glaciers were sliding down. Yosemite is especially notable for its waterfalls, with the water flow continuing to influence the landscape. Erosion, induced by rainfalls, earthquakes, and groundwater levels, may generate rockslides, resulting in deaths and property destruction. Conclusion. The Yosemite landscape evolved from a continental edge uplifted roughly 100 million years ago by subduction. For hundreds of millions of years, the park's landscapes were formed into what they are today. The Sierra Nevada range, which includes Yosemite Valley, was formed due to tectonic and volcanic activity. The terrain was gradually formed by subduction, erosion, and glacier activity. Consequently, mountains, granite intrusions, and valleys were formed.